So what I'll be doing is going through, again, it's not going to be like this machine learning oriented talk. It's going to be more about kind of what a workflow looks like and what kind of building a coherent, consistent, readable code looks like in R specifically. And though, in terms of what my inspiration for talking about this was I started working on kind of this more data science-y type problems and coding in these maybe roughly a year ago or so. And part of that, I had more of an analyst or kind of researchy background, so I was using Excel a lot and maybe SAS a little bit. And so when I was getting into this space, in terms of this kind of common idea of these skill sets of, computer science, math, and domain knowledge, my big weakness area, and still I'd say my biggest weakness area, was in computer science. So I didn't have a ton of experience with coding and following some of the good practices around building things that are readable and reusable. So when I started in the space, I would just kind of go to Stack Overflow, go through a bunch of different spaces and just like pull one snippet of code from one place, pull a snippet of code from another place, and then when I was building a solution, I'd have this just kind of like Frankenstein mix of different pieces of code that were really hard to read, really difficult to make changes to, and where I didn't really understand what was going on. And my kind of aha moment in terms of actually getting a more coherent, consistent framework was when I just like took a week aside and went through that R for Data Science book that I mentioned and a few other resources and got used to using a kind of consistent, coherent approach to solving problems. So that's what I'll be talking about today, and this whole kind of world is referred to generally as the Tidyverse, and it's focused on just building readable, reusable code, and also using a set of packages that are optimized for performance and that play nice with one another, and that work consistently regardless of the kind of process you're working on in this kind of data science workflow. And a lot of these principles are consistent whether you're using R or Python. Again, this is going to be a purely R example, but having the things that I really want you to leave with are just like an appreciation for building readable, consistent code for data science, especially if you're maybe coming from a more analyst type background where you're not used to needing to have something that's follows this type of flow. And the steps I'll be going through with this are first going through a few examples with the Iris data set, then a few examples specific to NetApp, and then going through a few key takeaways. So this is a slide that Stephen showed earlier in terms of what some common parts of the data science workflow are. And what I'll have is this will be kind of a place to ground what I'm talking about. So I'll have in the corner throughout my slides something that just kind of says where we're at. So whether I'm talking about modeling or transforming or visualizing, this will be some kind of key piece. So where these are some important parts of the data science workflow and what I'm talking about at that moment. So first, a few weird little peculiarities about R, especially if you're not familiar with it, things that may trip you up when you look at the code, so I just want to get these out of the way. One is that this kind of less than minus sign is R's assignment operator. You could also just use the equal sign. Something else to be aware of is that the periods on the next to characters, they don't actually, they could just be part of the name. So here you've got sepal.length, that could just be sepal length. In this situation, so the dots don't necessarily signify anything special. Also, the pipes, this percent greater than percent sign are R's version of pipes, and all those do is essentially say, okay, take the steps you've had up to here and then pass that on to the next step. So it just like moves things along. And pipes are very, very central to the Tidyverse and this kind of tidy approach because they help to break things into these logical chains of step-by-step processes where you can see, okay, first you're doing this, then you're doing this, then you're doing this, and it makes it much more readable. One little quirk is that for ggplot2, which is the visualizations I'll be using here, the plus sign at the end of the line signifies the pipe sign. So just know if you see a plus sign on these visualizations, that's a pipe. So now, for my first few examples, as I said, I'll be using the Iris data set. The Iris data set is a famous data set that has samples of different irises, different species of iris, and measurements on things like the petal length and the sepal length. So that's the data set I'll be going through here. And this first example I'll be going through is a transformation. Again, I'm going to be going through each of these different types and showing how you can make a kind of consistent flow for each of these and how there's this kind of coherence style and approach, regardless of the type of task you're doing. So when we read this, this is saying the first step we're just saying, let's get our data, let's get our iris data. So here you can see this is the iris data that we pulled up. And we're going to then pipe this or pass this into this select function. And this particular select function is saying, okay, take all of the columns except for the sepal.length. So we'll see the select function is just going to remove that column. Now we're going to say pipe that into this next step, which is a mutate function. And mutate functions generally either create new variables or they make changes to existing variables. And we're saying pipe what we have up to this point, and then this mutate function is going to say, okay, if it's numeric, do a log transformation on it. So you'll see all of the numeric columns will get a log transform performed on them. So that's what happens here. And again, this is just kind of this easy step-by-step process, and where you can see, okay, first start with the data, then do the select function, then mutate it. The alternative to this is to build code like this at the bottom here. This is the exact same thing, but it's very hard to read. It's this kind of, it's very short, but it's not easy to track. It's not how the human eye works. Here you have to read it inside out, where you're starting in the middle with this iris. The iris data set's right there in the middle, and then you have to read out to the mutate if function. And then you have to read outwards from there to the select statement. As I said, I came from an Excel background, so I would always build these huge Excel functions that just like had a bunch of parentheses on the end. But when you're building a coding workflow, it becomes really hard to read that as you start to get more and more complex tasks. So that's why you want to use the pipe to kind of split up the steps of what you're doing. And that's very integral to kind of how you approach using this Tidyverse type style. So now I just showed a quick example of a transformation step. Let's say you want to visualize this. Again, it's kind of a very similar type workflow. We're saying, okay, we have our data. We want to pass this into a plot function where we'll have on the x-axis our sepal length, the y-axis our petal width, and color being species. So we're opening up this plot. And now we're going to say, let's populate this with points. And then let's add some smooth lines across each of these different species. And you can see this is the same type of like step-by-step flow as when you're doing a transformation. Let's look at then what this looks like for modeling. We'll see a very similar type of workflow. Here I'm building a simple linear regression model where I'm trying to predict the sepal length based off of the other variables. So I just built this very simple model. But as soon as I built this model, I'm going to want to start doing transformations in my original data set maybe. Maybe I want to see what that model, what kind of predictions that would add. So I can then take my data and let's pass it into an add predictions function using that model I just built. So again, I'm going straight into transformation. Here I just added that predictions column. You'll notice that the pred column is pretty similar to the sepal length column because it's trying to predict what those values are based off of the other inputs. And let's do another transformation. Let's get the residuals. So I just add the residuals on. And so we just went from modeling to transforming, and now that we have this kind of new transformed data frame, we may want to visualize that so we can see what those residuals look like. So I'm going to then pass this into a visualization task now. So so after we've done this transformation, now let's pass it into a plot where we have on the x-axis sepal length, the y-axis the residuals split by color, and we're populating that again with points. Let's say we want to facet this, splitting it by the species. So let's split this into 3 separate plots. Again, this is a very consistent style, whether you're doing whatever kind of like data science-y step in the process you're doing. You've got this kind of coherent, consistent flow that's easy to read, easy to debug, easy to share with people.